Alright guys, good afternoon. Hope things are going well this afternoon. I'm going to talk you through a couple things in section 6.6 that I think are going to help you out. So we are going to solve radical equations. First things first is I'm writing on my iPad right now, and my handwriting is bad as it is, but it's worse on the iPad, so sorry about that, but you're just going to kind of have to bear with me. So we're going to solve radical equations today. And what are radical equations? A radical equation is if a variable is underneath a radical. So if you have this, that's a 3, this right here, that's an example of a radical equation. Okay, so in order to solve a radical equation, we have to get the radical by itself and undo the radical. It's kind of the opposite of if we had, if we had x cubed, we would cube root. Okay, so if we have a cube root, we're going to cube both sides, but first we got to get it by itself. Okay, so let's get rid of this. So let's go ahead and isolate the variable here. So let's subtract 4. Okay, and the cube root of x is now equal to 11. So then we would cube both sides, and x would equal 11 cubed, which is 1,331. Okay, bingo. Now you plug this back in, and then you cube root it, and you add 4 to it, and you're going to get 15. Okay, so fairly easy. Let's talk about a couple little tougher examples here. Alright, so 3 plus the 4th root of 3x minus 2 equals 7. So first thing is subtract 3 from both sides, and we get the 4th root of 3x minus 2 equals 4. Okay, now when we take both sides to the 4th power, okay, these cancel out, so now you're at 3x minus 2. Now this is not plus or minus on the right side. This is just 4 to the 4th power. Okay, 4 to the 4th power is 256. Okay, 256. There you go. Okay, so this whole plus or minus deal only happens when we square root or 4th root, but when we're taking sides to the 4th power, okay, no more plus or minus. So now we have 3x is equal to 258, and x equals 258 divided by 3, 86. Okay, now let's go ahead and plug that in, make sure it works. Okay, 3 times 86 minus 2, yep, 4th root of that gets me back to 4, and 3 plus 4 is 7. Bingo, got it. Alright guys, example number 3 here, and this is, we're going to do 4 of these. Let's talk about this one. Here we have a variable underneath 2 radicals, or underneath 2 different radicals I should say, and both on the same side, and this minus sign is kind of intriguing to us, so we got to pay attention to that. So it's not going to let me erase that. Yeah, it is. There it is. Okay. So, and we have this equation equal to 0. That helps out as well. Now here's what we can't do. What we can't do is we can't just go ahead and square everything in this equation. Why? Because, I mean, we should know at this point that if we have an equation, we can't just square, square, and square if this is an addition sign, because that would mean that 1 plus 4 equals 9, and that's not a true statement. So, can't do that. So what can we do? Well, it actually involves moving this to the other side of the equation, so then we'll end up having a square root equal to another square root. Okay, so let's go ahead. This isn't quite as easy to work with as the smartboard, but we're going to take this square root of 2x plus 10, and we're going to move it to the other side by adding it. Okay, we're going to add the square root of 2x plus 10. Okay, and just get it to the other side. Okay, bingo. So now we have the square root of x minus 3 equals, gosh, the square root of 2x plus 10. We're really going to have to work on my handwriting here. Okay, now that we have a square root equal to a square root with no addition, subtraction signs, separating any radicals here, now we can just go ahead and square both sides. And this would be a true statement to do that. So then those cancel out. Now we have x minus 3 equals 2x plus 10. Okay, so now we can solve this equation. This is Algebra 1 stuff. And we'll end up getting x is equal to a negative 13. Okay, subtract the x, subtract the 10. Now we can circle this, and that's fine. This is pretty intriguing, though. Okay, because if we take negative 13 and plug it back into the original equation, and what we'll get here is we'll get the square root of negative 16. I'm going to stop right there. That can't happen. That's 4i. And now we're not dealing with real numbers. So actually, negative 13, we didn't make any mistakes here, but the number that we solved for doesn't end up working out in the original equation. And the reason why is because when we go ahead and square both sides, we take away the square root. And so now we take away anything that couldn't exist in a square root, because now it can't. We just have an equation here, and that's no good. So if we find an answer, we want to make sure it works in the original equation, and if it doesn't, this is called an extraneous solution. So go ahead and write that down. Extraneous. Okay, so we have no solution here. No solution is what you're going to want to put here. This one ends up being extraneous, so we have no solution, and I wanted to show you one of those. We always have to check our answers in radical equations to make sure they don't produce a negative underneath an even root, period. Alright. Alright guys, last example here. We have this equation, go ahead and write it down. And again, we're talking about square roots, and this one is interesting because we don't just have a square root equal to a square root. We have a square root equal to a square root and then minus 2 here. So again, once again, it's not an option to just square, square, square and get rid of, so don't do that. This is bad. Bad, bad. Okay, so let's erase that. Hopefully it'll let us. I don't know why it doesn't let me erase these two. That sucks. No idea why. But forget they're there. Okay, what we can do is we can square both sides in total. Right? That's true. Okay, so now we just have x minus 12 over here. But here, the square root of x minus 2, and then if we squared it, is this. Oh my gosh. Undo. Bingo. The square root of x minus 2 times the square root of x minus 2. Okay, so write this down with me. Okay, so let's work on this for a little bit. Let's FOIL this. Square root of x times the square root of x is x. Oh my god. I don't know if you guys see this, but this is just... No, I want this. Okay, it's just x. Good. Now, outside is minus 2 times the square root of x. Okay, inside is another negative 2 times the square root of x. And last is a positive 4. Okay, and that's still equal to x minus 12. Okay, so nice thing here is this x and this x will end up canceling out. Okay, you could subtract x from both sides. So I'll go ahead and do that now. Subtract x, and those go away. Those go away. So now we're left with negative 12 equals, and at the same time here I'm going to combine these. These are like terms. Okay, negative 2 root x minus 2 root x is negative 4 root x. Okay, and then we have plus 4. So let's subtract 4 here now, and we get negative 16 equals negative 4 times the square root of x. Divide by negative 4, and we have the square root of x is equal to a positive 4. So then x gets us back to 16. Okay, and That's our answer. It works here. It works up there. It makes the equation true, the original equation true.